The overall goal of this procedure is to generate large numbers of infected zebrafish embryos for high-throughput compound testing to enable drug discovery. This is accomplished by first using a large breeding vessel to obtain large numbers of synchronous zebrafish eggs in a single event. Next, the eggs are aligned into an agarose grid and infected with bacteria in the yolk using an automated microinjector. When the infection has spread through the embryos, they are pre-sorted by large particle flow cytometry before being treated with drugs. Finally, the bacterial burden levels in infected embryos are analyzed after compound treatment. Ultimately, high-resolution analysis through confocal microscopy, vertebrate automated screening, and large particle sampling are used to show, with more detail, the effects compounds have on the infection.
The main advantage of this method over existing techniques like manual injections or pixel count analysis is that with it we can generate a large amount of homogeneously infected embryos, which we can analyze in a high throughput manner.
To prepare S. epidermidis inoculum, isolate several individual colonies from a plate of S. epidermidis strain 047 containing a PWVW189 derived M. cherry expression vector and inoculate 25 milliliters of LB supplemented with 10 micrograms per milliliter chloramphenicol. Incubate overnight at 37 degrees Celsius to mid-log stage. The following day, centrifuge 1 milliliter of the culture at 12,000 Gs for 1 minute and use 1 milliliter of sterile PBS with 0.3% volume per volume tween 80 to wash the pellet 3 times.